Okay, we are live. We'll quickly go through chemistry. Right, here's the first question. It says, welcome to your chemistry paper. We're doing February, March 2026, and we're doing paper 2-2. It's 45 minutes long, so ideally you would have needed to do it in a short amount of time. I mean, we don't have time either, but then I'm just going to quickly introduce you to this paper, and you can continue it, and we'll continue together. Here is what it says. It says that right, remember that we have 12 chapters for chem for everybody. Remember that we have the 12 chapters, so we'll be talking about them as we move on. A sample of helium gas is placed in a syringe. The temperature of the don't read it too deep. Skim through and understand what the question wants from you. Don't go too deep because it can confuse you. So the temperature is increased. This is a key statement. The pressure does not change. Okay, so no problem. Which statement is correct? So if pressure does not change, we are not looking at it. Remember, I said we study PVT, pressure, volume, temperature. If pressure is constant, that means we are not analyzing it. We are looking at the relationship between volume and temperature. We are looking at the relationship between volume and temperature. So the temperature is increased. What happens to the volume? The temperature is increased. What happens to the volume? That is all they are asking you, basically. Let's go through the questions and let's see. Now, what I want people to know is that here is how the relationships work, because these relationships can get you down. We all know that pressure and volume are inversely proportional. But once you start to say temperature and something, then it will always be. If you are keeping pressure constant and you are changing the temperature, the volume will also increase. If you are keeping volume constant and you change the temperature, the pressure will also increase. So these are basically this is the summary of the relationships. This is what you expect to have. Okay, so here what is it saying? Which statement is correct? The volume of helium decreases. No, that's out. The volume decreases. No, please. The volume increases. Okay, yes. And the helium atoms get closer together. How can you say that? That's wrong. You can't have the atoms get closer together when the volume increases. The volume of helium increases and the helium atoms. Volume is of the container where your helium is. The space being covered by these particles. So here the volume of helium increases. They're covering more space. And the helium atoms get further apart. Yes, they're covering more space. An experiment, so that is your question. That is no number one. And you move on to number two. The number two question says now, an experiment is set up as shown. Okay. Which row describes the first change in universal indicator paper? So this is a typical question, students, that tests how much diffusion is affected by the mass. This question here is a question on diffusion, where you're going to have a cotton wool soaked in concentrated hydrochloric acid on one side. Then you have a cotton wool soaked in concentrated ammonia. So here we have concentrated hydrochloric acid on one side, concentrated ammonia on the other side, and a damp universal indicator paper. Now, this says, which row describes and explains the first change in the indicator paper? Who gets to the paper first? Is it the concentrated hydrochloric acid where the cotton wool is soaked in on one side, or is it the concentrated ammonia? Here, did you see the question? We have concentrated HC. They are telling you that you have concentrated hydrochloric acid. A cotton wool is soaked in concentrated hydrochloric acid on one end. Then you have cotton wool soaked in concentrated ammonia on another. Then you have your damp universal indicator paper in the center. Now you have been told that the concentrated hydrochloric acid on one side gives off HCl gas. What does it do? It dissolves in water to form an acid. It dissolves in water to form an acid. And this universal indicator is damp. Then the concentrated ammonia gives off ammonia gas, which dissolves in water to form an alkali. Now, what color will our universal indicator be? Right. So the first question we have is universal indicator. What does it become? What does universal indicator become? Is universal indicator made red when it has an acid, or is it made blue when it has an acid? These are the colors you should know about universal indicator from acid, bases, and so on. When you have a strong acid, universal indicator is red for strong acid. These are the colors. For very strong acid, which means pH will be 0, will be 1 or 2 pH. That means it's a strong acid. Very low pH means it's an acid and a strong one. Then your universal indicator starts getting yellow or orange when your acid is becoming weak. Orange or yellow when you have weak acid. So this is for weak acid. It becomes orange or yellow. That means your pH is like 4, 5, 6, but it's not 7. 7 is neutral. For neutral, universal indicator is green. That is neutral. Then it is going to become blue for weak base and purple for strong base. Purple for strong base. So, anyway, red is always for danger, for acid, and blue is for bases. It's always like that. For litmus papers will always be red for an acid as well. So if you bring a red litmus paper and you dip it in an acid, it will stay red. If you bring a blue one and you dip it in an acid, it will go red, because acid makes everything red and the bases are blue. So here we know. So now all we want to know, we know that we have HCl gas. We no longer see this as hydrochloric acid. We see this as HCl gas on this side. Then we have ammonia gas on the other side. So we have HCl gas on one side, we have ammonia gas on the other side, we have a universal indicator in the middle. Which one diffuses faster? Which one is heavier, and why? So diffusion, we said, it is affected by how heavy something is. Now, if we have it, look at this. Ammonia is NH3. Okay? This is going to have a mass of what? Nitrogen in your periodic table. Go and check. You should see it's 14. Then hydrogen is 1, but there are 3 of them. So 3 by 1. And when you add, you get 17 as the mass. Now you come on the other side, you have HCl. Chlorine alone is 35. 35.5 or whatever. Hydrogen is 1. So together they will give you 36.5. So this is heavier. So it diffuses slower. So ammonia will go get to the universal indicator first. And because it is an alkali, we expect to see blue. So B is out, D is out. Now let's say A and C. A is blue because molecules of ammonia move more quickly. Yes. So diffusion, they like to test it like this. And you must know that they are testing you to show you that diffusion depends on their mass. The heavier something is, the slower it will diffuse. That is it. So molecules of hydrogen chloride move more quickly? No, it is heavier, so they can't. Anyway, here is an ion of group 2 element X. Okay, what is the highest value in the ion? What is the highest value in the ion? So you have this X2 plus. Well, let's talk about it. Can we talk about what we call nuclide notation? Okay. we want to talk about what we call the nuclide notation that you meet in periodic tables. So in periodic tables, you meet what we call nuclide notation, which gives you two numbers A and Z. If we go to the periodic table at the bottom and we see the nuclide notation given, they give it. Here is the nuclide notation, X. And they're saying there is atomic number at the top and there is atomic mass at the bottom. Mass is the one which is called A. Number is the one which is called Z. So Z is for number. For mass, it is A. Right. So we know that mass is always bigger than atomic number. Let's go and let's see. For everything, mass is always bigger than atomic number. You can look at the periodic table and see. So if we come here now, look at what was happening. Atomic number here. Since this is now a positive charge, it has lost electrons. So here, if we look here, by the way, mass number, which is given at the bottom, is going to be protons plus neutrons. And protons never change. Protons never change. They have a constant number. But this one, which is now 2 plus, so this is an X2 plus ion from group from element 2. And what they want to find is what is the highest value that you find on the ion. You'll be looking at, this is called the nucleon number, the one at the bottom. It is the one that is found by you adding. It's the things found in the nucleus. So atomic mass is nucleon number. It's called atomic mass. It can be called nucleon number because it talks about the things in the nucleus. So if you find here, the things you had was nucleon number, electrons, neutrons, and proton number. Now, did the nucleon number change? Did the nucleon number change? Because, students, did the nucleon number change because it is now an ion? No. What is changing is the number of protons. The nucleon number is not changing. What is changing is the number of protons. So now, if they come and they ask us, what is the highest value in the ion between nucleon number, number of electrons, number of neutrons, and proton number? What is the highest value? We know that we have nucleon number, we have electrons, we have neutrons, and protons. Now, this will always be the biggest value. And you changing the value on top here does not change the number of protons. What about the number of neutrons? No, doesn't change them. What about the number of electrons? If it's positive, it actually reduces them. So this has nothing to do with them being better. Nothing is more here. Neutrons are not touched by ions. Proton number is not touched by ions. It's only electron number that is affected. But guess what? This thing is positive, which means it has lost electrons. So they can never be bigger than nucleon number. It was originally the biggest, but nothing has been changed for these two. And this one has actually gone down, so it stays the biggest. Because it is the sum of neutrons plus protons. So it's obviously the biggest. What is the formula of this compound? Well, okay, they said these two things react together. What is the formula of the compound? This cannot be easier. This is group 1, this is group 2. transition: group 3, group 4, group 5, group 6, group 7, group 8. All right. Group tells you the number of electrons in the last shell, which is the valency. This is in group 7, so that means it only needs 1 electron. This is in group 1, so that means it is giving away 1 electron. So it will give the 1 electron to this one and they bond. So their ratio is 1:1. Your answer is A. You look at group number. It tells you the electrons in the last shell. Good. Which row describes the properties of a simple molecular compound? So here we want to look at the properties of simple molecular compound. What types of compounds do we have for IGCSE chemistry? We have simple molecular compound, 1. They are also called simple covalent compounds, like hydrogen, oxygen, water. Simple molecular compound is also called a simple covalent compound. There is no metal there. Water, oxygen, methane, all these things. Then you go to the second, which is called a giant covalent. Because that may be the one they may ask you. Giant covalent structure. And you have to know 3, which is diamond, graphite, and silicon dioxide. You must know. Okay? These are the 3. We have diamond, graphite, and silicon dioxide. We'll talk about their properties. Then you have ionic compounds. Then you have metallic bonds, whatever. So we can say ionic compounds. Okay? These are, for example, sodium chloride. For example, magnesium oxide. Calcium oxide. Let's do it. Calcium. Let's say calcium chloride. Metal and non-metal. This is ionic. So what do we know? What do we know about, let's say, for example, the giant covalent structures? What are they? What are their properties? The diamond, the graphite, the silicon dioxide. What should we know about them for IG Chem? You should know that. Where is the red? Here. Diamond is the hardest on earth. It is the hardest it is the hardest material on earth. You can use diamond to scratch the surface of anything. What if we break the diamond? It's precious. It's hard. Don't worry. It's hard. It has a high melting point. Okay? It has a very, very high melting point. But its weakness is it does not conduct. So not a conductor. On the giant. Make sure you're seeing this. Graphite, on another hand, same thing. High melting point as well. But we don't say it's hard. It's soft. Graphite has layers. It's soft. And it's slippery. But the benefit of this one is it conducts electricity as a solid. Diamond can't, but graphite can. Graphite can conduct. What about silicon? It can't. Not a conductor. It's like diamond. Only graphite can. But again, it is hard and it has a very high melting point. So for simple molecular compound now, okay, this is for the giant. I wanted to make sure you know for the giant. For simple molecular compound now, you need to know that these generally have very low melting points and very low boiling points. Low melting points, low boiling points. They can't conduct electricity. So that's what you expect. They cannot, these simple ones, simple molecular, they can never conduct. For giant molecular, which means giant covalent, they only conduct when it's graphite or when molten. Ionic conduct even in solid state. All right, we'll talk about it. Now, ionic conduct when molten, I mean. The only things that conduct even when solid is metals and graphite. So metals, we'll talk about metals. But ionic, they need to be, you melt them or dissolve them. Then here we have some covalent here can never ever conduct even if you melt them because they have no ions. But for metals, they conduct even as solids. Metals and graphite. These are the things that conduct electricity. So now here they are saying melting points. Look at electricity first. It must be a poor conductor. So these ones are out. Now, it must then have low melting and low boiling point. So you are left with C. This is too high. There we go. Because once it has high melting, high boiling, it may be diamond or it may be silicon dioxide. Now, how are the structures of diamond and silicon dioxide similar? Well, this is the next question. So we have already talked about their properties. Now we are seeing how the structures of diamond and silicon 4 oxide are similar. Okay, how are they similar? Here's how they're similar. What you must know is that they are giant covalent. So they have a covalent lattice. So it means when you look at their atoms, they are going to be joined by covalent bonds in 3D. So it's a 3D. So this is special. Very, very special. So if you see here, the carbon in diamond and whatever, each have 4 covalent bonds. That's good. They both contain free ions? No. They both contain ions held together by the atoms? No. No. So your answer is D. Your answer is only D. We don't talk about weak attractive forces. It has to be strong. That is why they have high melting and high boiling point. And they are covalent bonds that hold them together. The weak is for simple, like water, oxygen, methane. That's where it means. Anyway, solid X and solid Y are both pure. Okay? X is not a conductor. Y is a conductor. Look, they are solids. The moment you have something being a conductor when it's a solid, either it's metal or it's graphite. All right. So why we already know, because it's like that. So here, look at what they're now saying. Which statements about X and Y are correct? So these are both pure substances that have ions. Now metals have ions. So graphite, you're out. Let's see here. Metals have ions. Remember, in a metal, you have big positive ions. Then you have your C of electrons moving around. C of delocalized electrons. So here they say, what statements about X is a compound, Y is an element? Y is an element. Yes. Y is a metal, so it must be an element. And X is not a conductor, and it has ions. If it has ions, and it's not a conductor, that means this is an ionic compound. It is because we know that ionic compounds do not conduct. Only metals do as solid. Don't forget. Why do metals conduct as solid? Only metals, because they are the ones that have free electrons, delocalized electrons. So don't forget that part. So anyway, that's good. Now let's see. So what are we saying here? X is, this sounds correct, 1. So if there is no 1, then you are out. So we are left with A, B, and C. The ions in X are held in a lattice. The ions in Y are not held in a lattice. Well, if they say the ions in X are not, the ions in Y are not held in a lattice, here they're saying in a metal that the ions are not in a 3D structure. That is not realistic. Here we have ions like this. And we said that metals, when you look at them, remember the properties of metals. They are malleable and ductile. The reason they are malleable is they have layers, and the layers can slide over each other. That's a lattice. So this 2 is wrong, and you cannot say that metal in Y, which we saw is our metal, there is no lattice. So this is out, this is out. Your only answer can be C. So if you look at number 7, you should get C. You go and check your solutions. If there is an error, you tell me on any question, but we are not seeing any error so far. Anyway, this keeps going all the way up to number 40. So I've introduced you to this, and I'm going to send you piece by piece as clips continuing this, and we'll see how it goes. Are we together, everybody? This is interesting. This is interesting for all of us, which means we should get to work. You can do this. So I want us to be doing these papers together. Can you continue from number 8 up to number 20? From number 8 up to number 20, and send me as ABCs. Okay, ABCs. Send me the solutions from 8 up to number 20. Send me right away. Continue number 8 up to number 20, and send me solutions tonight. Everybody in the lesson, thank you. Bye. Don't forget to send me number 8 up to number 20